All right, class. So on this first podcast for naming, you're just going to fill in the blanks at the very top of your notes packet, and it's simply going to be metals is the first blank. I'm not going to write that there because I am sure it's going to look terrible if I try to. But metals with only one charge. So there's basically 5 things that fall into metals with one charge. So it's the first 2 columns of the periodic table. So you have the alkali metal and alkaline earth metal. So second blank is alkali metal and alkaline earth metal, and 3 specific other elements. And that's just our bing, 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 or silver, zinc, aluminum. And these 5 metals, really 2 columns, 2 families, and 3 metals, are the metals that have the same charge all the time. So alkaline metals are always +1, alkaline earth are always +2, and silver is 1, zinc is 2, aluminum is 3. And they're always positive charges because metals, we'll learn more about this second semester, but they lose electrons and become positive. Okay, so when we name the compound, the metal is always written first. So the things on the left side of the periodic table are metals, and the things on the right are nonmetals. So the metal is written first, followed by the nonmetal, whose suffix is changed to "ide." Okay, so if we look at this first example, we have Ki, and so right here, so K, if I underline this, is an alkali metal. Okay, so it's one of my 5 metals. So I'm simply going to write K's name, and it's potassium. And then iodine, I'm changing its ending, its suffix, from iodine to iodide. So that compound is called potassium iodide. Good enough? All right, next example, we have sodium. So sodium, again, is an alkali metal. So anytime you have an alkali metal, an alkaline earth metal, or bing, 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 we're going to name it like this. Okay? So Na is sodium. And chlorine is going to become chloride. And this is just simply table salt, is sodium chloride, or NaCl. All right, and lastly, we have magnesium Mg, which is an alkaline earth metal. Okay, so this one actually throws in what's called a subscript. That 2 doesn't matter when it comes to naming if we have a metal that's an alkaline earth metal, or bing, bing, bing. So we're simply going to name magnesium. Magnesium. And Br is bromine, but it's going to become bromide. All right, so we have magnesium bromide. The next thing with stars, this is super important. Blank compounds will always end in "ide." So I'm going to put, or I would have you put, non-metal compounds will always end in "ide." So if you have a non-metal by itself, it's going to end in "ide," no matter what the naming is. That's one of the things that will stay consistent throughout. Okay, so that is naming. The next thing we're going to go is writing formulas. So this time we're going to start with a name, and we have to write the formula. So this is always true. The positive charges must equal the negative charges. Think least common multiple. So what I would do on these is, we have strontium phosphide. So I would go ahead and write strontium. And you might just go ahead and write the phosphorus as well. So it's phosphide, so we know its ending changed to "ide because it was a nonmetal. Okay, so we have SRP. So strontium is an alkaline earth metal, so its charge is a +2. And phosphorus comes from the 3rd family in, so it's a -3. So if we add these if we add these charges up, a positive charge and 3 negative charges, that sums to -1. Okay, that is not good. So compounds have to be neutral. Neutral means they have a charge of 0. So we want to find the least common multiple of 2 and 3. So the least common multiple, again up here we have think least common multiple. So the least common multiple of 2 and 3 is going to be 6. So I'm going to put a 6 right here. So what times 2 is 6? 3 is. So I put a 3 down here, and that's just signifying I really have 3 strontium. Okay, so if I have 3 strontium and each has a +2 charge, overall strontium is contributing a +6 charge. Okay, similarly, what's the least common multiple of 2 and 3? It's 6. So 3 times what is 6? My lights keep turning off in my room, so they're on a timer. All right, so -3 times 2 is -6. So +6, -6 is 0. Okay, we'll do another example, and that's going to be the lithium oxide. So let's move it over here a little ways. So we have Li, and it's going to be with O. And what is lithium's charge? It is +1, because it's an alkali metal. And oxide is a chalcogen, so it's a -2. So this is a little bit easier. We kind of started with a hard example. But lithium is a +1, oxygen is a -2. So the least common multiple of these is 2. So really, I need 2 lithiums for every 1 oxygen. And what you find, even from our examples above on Ki and NaCl, if we have 1 of something in chemistry, we don't put a number there. So if you put a 1, I'm not going to count it off. It does look kind of strange to me, but if you want to put a 1 as a subscript, that's fine. It is not necessary, though. Okay, so this 1 right here is not necessary. All right, so lithium oxide is written Li2O. All right, lastly, this is kind of just a shortcut to do this. This works most of the time, but not all the time. I actually have an example that is one of the times it doesn't work, but the crisscross example. So if I write calcium and sulfide, calcium has a +2 charge, and sulfur also has a -2 charge because it's a chalcogen. So if I just do arrows, okay, so I'm just going to put an arrow this way and an arrow this way. So if I just crisscross my charges, okay, so I'm going to put a 2 here and a 2 there, that will also give me the right answers. Okay, so if I go back up to the strontium phosphide example, notice my +2 comes to phosphorus, and my -3 goes to strontium. And over here on lithium oxide, +1 goes to oxygen, -2 goes to lithium. All right, so when it's tricky, like this is currently not correct. So if we're talking about ionic compounds, so metals with nonmetals, if I can reduce these, so notice they're both 2, and 2 can be reduced because it is like the least common multiple of 2 and 2 is 2. But if I can reduce these, so if I had a 2 to 4 ratio or a 3 to 6 ratio, or I'm not sure, that's probably the only ratios you're going to see. But because I have 2 calciums for every 2 sulfurs, I would really simply write this CaS. All right. So calcium sulfide is just calcium sulfide, CaS, because I have 2 of each, so I'm going to simplify that. So if you can ever simplify them, if you crisscross it and they're both divisible by 2, both divisible by 3, go ahead and simplify it, and that will give you the right answer. So that is the end of this podcast.